Welcome back everyone. We're going to take a look at the last theory of paragraph 7.3, calculating angles in triangles. And this piece of theory doesn't really introduces us to something entirely new. What we're now going to do is we're going to combine all the rules that we know up until now to calculate angles inside of triangles. And from here on out, you will see that the calculations are going to be a bit longer than we're used to. So it's even more important right now to always write down which rule you use or used to calculate an angle. Okay. Which rules do we know up until now? We know that if we have a right angle, like angle A, that if I have divided this with a line like this, that angle A1 plus A2 must be equal to 90 degrees. This is the right angle. A straight angle is 180 degrees, so if I divide it with a line like this, that means angle B1 plus angle B2 together must be 180 degrees again. We know that opposite angles are equal, so right here angle S1 is equal to angle S3, but you could also say that angle S2 is equal to angle S4, right? The sum of three angles in a triangle is 180 degrees, the angle sum of a triangle, right? We know that in an isosceles triangle, the base angles are equal, right? Angle Q is equal to angle R. And we know that a bisector divides an angle in exactly two equal parts. So right here, angle T1 is equal to angle T2 because this line is a bisector. How can we use this? First of all, what I'm going to show you now is the example that's also in your book. If you want more examples, please take a look at the other videos that I will record that will take a look at some actual exercises from the book, okay? And then I will use Active Inspire to actually draw and write myself. Here I'm just going to use this example first. So let's take a look. In triangle ABC, in figure 7.27, angle B, this one, is 30 degrees, angle C is 52 degrees. Furthermore, AD is the bisector of angle A, so that means that A1 is equal to A2. They already give you that in the drawing as well. Calculate D1 and calculate angle D2. First of all, if you do exercises like this, you will find there are multiple paths to the final answer. Always go to Rome, you could say. But it's still important to try and come up with a plan first before you start calculating, because sometimes when these triangles are going to be more complex and you get more angles to choose and which you can calculate, sometimes you're going to spend a lot of time calculating things that you didn't have to calculate actually. So right here, I don't even know which way the book comes up, but which way I would use, I think, is in this triangle ABC, I know all the angles together must be 180 degrees, right? So I know that angle A can be calculated. And if I know angle A, I know that if I divide it by 2, I can also find the value for angle A1 and angle A2. Let's see if the book agrees with me. Yeah, they calculate angle A12 in triangle ABC using the angle sum methods. And then they say calculate angle A1 first because of the bisector, and then calculate angle D1 in triangle ACD. If I know angle A1, I can use the angle sum method here as well. And then I can calculate angle D2 either by doing the angle sum method in triangle ABD, or you could use your knowledge of the straight angles to calculate it if I know D1. Let's see what the book does. They use the straight angle method, okay? Or I have already included it even. Or calculate angle D2 using the angle sum of triangle ABD. So there are multiple ways here. As long as you write down which rules you used, it's okay. Okay? So here I would start by writing down, or do it in one step, it's also okay. Triangle of angle A12 is 180 minus 30 minus 52. equals 98 degrees because of the angle sum triangle. And I know that angle A1 and also angle A2 actually is 98 divided by 2 equals 49 degrees. So this one is 49 degrees and this one as well because of a bisector. Now I can calculate angle D1 by using the angle sum of a triangle again. And I could use the same method to calculate D2. But I think they use a straight angle right here. Right, they say this whole angle is 180 degrees. So angle D2 must be 180 minus 79. Use the way you like the most. Practice this a lot. Don't forget to write down which rules you used. And if you find this difficult, please watch my other videos about other exercises from this chapter as well. And don't forget to ask questions if you have any left. Good luck to you all.